Hey, you're got a pretty good quorum here.
Good.
How's it going? So, yeah, I should probably start publishing agendas for these things. I just can't get that organized, but but I appreciate people showed up. Uh, Today, yeah, I really wanted to get out the V5 and the guest side stuff ahead of time. There's some new things in there. Anish and Lexi, you guys have taken a look and given some feedback. I want to see if we can talk through concerns items with that, like, and try to get it settled down. I can talk through some of the bigger changes. Um, but before we dive into that kind of code review or that kind of details, I wanted to share. Um, I wanted to share a diagram that I've been like, because everybody always has questions about how this stuff's going to go upstream. I'm assuming you guys are also fielding those kind of questions. I wanted to walk through a couple of pictures I've shown people and um, get us who are doing the upstreaming on board with um, or on the same page with how the stuff's going to go. So let me see if I can share this. Hold on here. Um, is there a share button on this thing? No. Okay, hold on. Okay, is this coming through?
Yes.
Yes.
Okay. Um, and Anisha, apologies. I should show ARM at the same level as everything else, but but a lot of when I drew this diagram, I had Intel and AMD on the
Yeah,
line,
I understand.
but
Yeah.
but ARM is equally welcome, and same as RISC V, so same was not here. But um, the overarching point is that we all have these things that are in these blue, green, yellow, blue, whatever boxes. Um, and those are our TSM pieces. These are the implementation specific pieces. This is the whole stack view, and then the purple is all the stuff that we don't control. Us in this room, we don't control these things. These are other maintainers that we have to convince to take our stuff, and all of these maintainers have other plans, other things they're working on, and so we're kind of having to convince them to take all this TIO bits and pieces, and the more that we are on the same page, the easier it is to go to Bjorn and say, "Hey, Bjorn, look, we all agree on these PCI core changes. I think it's time to merge them. They've been sitting in a staging tree. We've all kind of worked together on it, and the vendors are all in alignment and that kind of thing. So um, uh, this is the whole picture I've been showing, and then I kind of broke it down into um, different phases of the work, and the phases mostly fall along like um, when I originally did this, it was basically it was done in the order of kind of the setup flow. So you do the physical side, then you connect it, then you assign it to the guest, then you do well, all that work to get it assigned to the guest, and then you boot the guest, and all these different phases. But uh, some of the most recent feedback is about phase one and phase two. So phase one was about, hey, let's just do the connect flow, and I think that's still valuable. I think we should do that first. I think this is the first thing we're gonna push patches for on the TDX Connect side. Um, but the hard stuff is really all these pieces over here. I don't know if you can see my mouse moving, but all these pieces on the on the right, the KVM, the DMA buff, the
I do see
VFIO
your
pieces.
mouse.
You don't see the mouse? Okay.
I do. I do.
Oh, I do. Okay. Okay. Um, and I think this is going to take a while to. I mean, like we look at like when Yilun did that one patch to export the PFN, it was this big long thread with Christian. So I think we'll get there, but I think it might take a little bit longer. But what I realized is through the review, other people's feedback is this kind of PCI TSM piece and the the 7 patch series that added the lock and accept. I feel like that if we get that done and the PCI core piece is done, and we teach the guest side to map MMIO encrypted, to do DMA mapping, private DMA mapping, that's actually a piece that we could upstream while the rest of the stuff is working itself out. That we probably don't need to wait for this entire debate to resolve about how this stuff goes, and we could stage the PCI core pieces first, and the device core and the guest side pieces first.
Yeah, there's also like on the ARM side, we have feedback to get that kind of sorted out.
Mhm.
That's also the way we have been kind of pushing the rest of the like CCA bits, right? Like if you look at gender outside the DA, the guest has gone upstream first. And
Mhm.
that's also because it also enables the distros to pick the guest bits quite early on, right? Because
Yeah.
the guest bits are like kind of generic and it needs to get into all the distributions and that takes time, right? The hypervisor is still can be managed by vendors, even though they may be using distributions and things like that, right? So there is a
Right.
desire to get the guest upstream first.
Yeah. It's also the piece of the solution that the cloud has least control over, because they want to let you bring whatever kernel you want, and it'd be nice if that kernel was upstream mainline
Yeah,
guest
yeah,
enabled. Yeah. And
yeah.
then on the host side, yeah, they can meet whatever interfaces they need, but that can spin at a different timeline than that stuff. So good. I mean, yeah. I and like Alexi, I assume you don't disagree that like we could probably get that people would like to see the guest side first. I mean, we're not saying we're not going to work on the host side, and we're going to have good ideas
No,
there
no,
and proposals, but
that's the right approach. Yes.
okay, okay. Um, so I think uh, so with that in mind, again, I think I would like. I don't know. I mean, no, 618 I think is out of the question, but I don't think 619 maybe isn't for kind of that guest side PCI guest side device core and DMA stuff. That's kind of what I'm thinking for those
Yeah,
pieces.
so the patch you posted, I was not so clear about the flow. I think there
Hmm.
was Jonathan also was kind of asking like, so we on the guest side we would have the driver would use a deferred loading. I mean, I kind of was not clear what. So I understand there is a lock
Oh,
and a subset of his files, and that's what we used for
yeah. Hmm.
transitioning the state to lock and then verify and accept the device after attestation. But from the PCI core side, with respect to managing the DMAs and things like that, I think you kind of introduced the concept of deferred loading of the driver, which I was not so clear about. And I think there was an email on the list from Jonathan kind asking like what's the actual flow there, right?
Yeah. Oh, maybe from Jason or from I didn't see mail from Jonathan. You
Yeah,
talking about Jason
probably
or John?
Jason. Yeah.
Okay, Jason.
Yeah.
Yeah. Yeah. Yeah. Let me explain that a bit more. So that is for the enlightened driver case, which I don't think is which I hope is not the common case. I'm hoping the common case is you see the device, you lock it, you get the attestation info, and you accept it, and then you load the driver and you're done. Um, that whole deferred probing thing is for a separate case of some people that have said like, hey, look, when we do device assignment, full device assignment, it may be the case that we have to do some work with the device before it's in a state where it can be locked and can be accepted. So the best thing to do that is have a driver do it, but the driver can't. The driver also, we also need to unload the driver when we do the transition, the final transition from lock to run. So this deferred probing proposal is basically to say like, hey, if you're an enlightened driver and you need a clean point in your initialization flow to say, okay, I've done everything I need. I've loaded the secure firmware. I've done all the configuration I need to do. I'm now ready to be accepted. You can call this. You call this routine that basically says you basically exit probe at that point, but and put yourself on the deferred probing list, and the and at that point, so as far as, and I think I wrote this in the I don't know if you saw my recent reply to Jason, but the flow would be you bind the driver that knows how to configure the device. It exits when it's done its configuration. Then
You mean unload the driver? Unload the configuration driver, is it?
well, I mean it would automatically unload because the probe would exit with an eProbe deferred.
Okay.
So it exits. So it does as much work as it can do, and then it says, okay, now I'm ready to be accepted. Oh, I'm not accepted yet. Now I enter the deferred probing queue, and then user space at that point has all the time it needs to lock the device, run the acceptance flow, and then try to bind the driver again. And the driver will go through all the same steps. Like the secure firmware is already loaded. Oh, the configuration is already set. Oh, this deferred probing check will pass because I am accepted, and then you can run then you're off to the races on the new flow. So it was kind of like, because Jason had a good point, and I agree with him that we should try to aim for unmodified drivers as much as possible. But this was like, hey, if you're one of these enlightened drivers that really needs to know if you're in this pre-configuration state, here's a helper you can use. But the piece that's missing though, and we need to decide, is a policy around devices that can be accepted. Do we need like a driver core policy that says, hey, do not try to attach to devices that can be accepted but aren't yet? That's a little bit different. That might be something like if you're in a guest and you see a device with a TIL capability, don't try to bind to it by default until user space says okay. But I left that part out of the patch because I think that the most controversial part of this is getting Greg to agree to what the accepted bits look like on the device, on the struct device.
The right now the flow is we will get the administrator to unload the driver and then transition the device to accepted state and then load the driver, right?
Yeah, I mean, yeah. So you can either have a driver that loads and fails to load, and then to do that configuration, and then try to lock and accept it. You can do that, or you can use this facility. Like it's kind of up to you. This was just a proposal of like, hey, if you have a common way to do it, here's just because my worry is that the normal device driver unwind flow might also destroy your lock state, right? Or like you might shut down things that, so you might want, like basically it's a recommendation. Recommend you just do deferred probing and wait for user space to come along and help you out with acceptance. But yeah, but definitely you could ignore this. You could ignore this altogether and just load the driver, fail it, unbind it, try again, kind of thing.
That would be TDISP aware driver, and for the first run, first mod probe, we could just pass a parameter to the module.
For a unaware driver, I don't think you need you don't need a parameter, right? You just
no.
Right?
For TDISP aware driver, because if it's TDISP unaware, then if it fails to probe, then it fails to probe. There is no point for testing and enabling.
Right. Oh, you're saying for that?
If you want to preload firmware and then unload the module, or say probe failed, like for this kind of case, you can tell the driver the reason why you're loading it. Like, please do firmware update and then just exit.
Yeah, and that was a part. I also told Jason, like, I'm not sure that we need to have I'm not sure that Linux driver core needs to have a common way to do that. Like, that may just be like if the vendor of the device knows they have special stuff to do, they tell their users, you got to load the driver twice. You got to load it once to do the setup, and then you got to do it again after you accept. But I'm not sure Linux needs to actually make a formal flow for that.
No, it doesn't.
I understand that your proposal is that you when it is TDSP aware drivers, then and you need some pre-configuration for logs, then you firstly probe the driver and do the pre-configuration, and then you defer the probe. Is it? And then when user space has done the log and accepted, and you and you probe this driver again.
Yes. Yeah. So so that's just but it's just a recommendation. You could achieve the same thing by just loading the driver failing and teach your driver unload fail path not to destroy configuration, and you basically achieve the same thing. But this is the common way.
What I'm missing from this.
Okay, go ahead.
What do we need to convince Greg or Björn? And
so I think,
why would they care if mod probe failed?
Oh no, I don't think that, so. I don't think they care about. I don't think they care about the probe deferral, because I think that's just typical Linux. Like, any driver can defer probing for any reason at any reason. I think the big thing the big achievement or thing that I think has kind of been elusive for the past few times, like that somebody's tried this. Like, we had this device firewall filter thing that came through, and that didn't go anywhere. And then the Microsoft had the confidential VM bus proposal, and they had like a flag in there to say don't bounce buffer, and that didn't go anywhere. So I'm just basically trying to pin down Greg and say, look, we need one bit, one flag, somewhere relative to a struct device, because we're going to need to query this thing from inside IOMMU drivers. Going to need to query inside other places. Just please act this proposal, and this proposal is hopefully acceptable, because it kind of it puts some form around it where you have to call the helpers to change it. It's not just kind of a public attribute on the struct. So far, he didn't really react to the proposal.
By the bit, you mean like force DMA encrypted kind of bit in device struct?
Yes. Yeah.
Right. Okay. Got it.
Yeah. And so because I think once we have a struct device bit that says that a device is part of is accepted into the T, then we can go enable all the other. Then we can go work with the DMA mapping subsystem people and get them to accept things. But yeah, until Greg signs off on that piece, I think we're kind of stuck.
I did have one question, like the deferred probing, like we actually put them into a deferred list, and during the latency is where we do the actual probing, again probe the device, right? Considering that all the resources needed for the driver is now ready, right? But we may not have attestation done by then, right? During the booting. I mean,
right, yeah.
So how is the default probing supposed to work with respect to an attestation workflow where the user space needs to talk to an external entity to get it attested?
So deferred probing has a boot time use case, but we're not using it for the boot time use case here. Like, in the boot time use case, you want devices that are present at boot to come up, but can't really guarantee the order, and so you it's basically always trying over and over again to bring up like those initial boot devices. In the case of TDIS, I'm expecting that we'll probably have some kind of policy somewhere, kind of like Jason asked for, which is we're not going to probe things by default. That we're going to wait for user space to come all the way up, and then we're going to see what devices are there and run UDEV scripts or administrator scripts to say, okay, I want to bring this device into my T, and then load the driver. So I expect this. I'm expecting that this flow is running late. It's kind of similar. I put that script at the back of the 7-patch series, and that's also doing stuff late. You load the module very late in the flow, post late init call, and it will still put it on the deferred probing list, but it will just sit there. It won't get if you're not in the boot process. It'll sit there indefinitely until you actually manually take it off that list by binding again. So it's just a
got that.
Yeah. So it's just a timeout, a holding place to put the device. But the nice property of it is, I mean, I guess debugfs is not always guaranteed to be mounted, but debugfs can tell you the reason why your driver failed to load, so you can at least have a check to be like, oh, did I fail because something's broken with my device, or am I just failed to load because, oh, look, I'm on the deferred probing list. So there's some kind of usability parts of that are nice. I don't know, Elon, did you have a follow-on question?
No. I don't have no more question.
Okay. Oh, so that was the. So yeah, so I think yeah, we're all in kind of agreement like that I think there's a path to get the PCI core kind of piece done first. Hold on a second here. So the other thing I've been having conversations with people like is the attestation piece, and this is where like this is the part of it that I've been saying like that there's multiple proposals. We're kind of missing a guest user space project to consume all this stuff. I'm pretty sure that we can get to a place where everybody's attestation material is standardized, like a standard format. I don't think it needs to be vendor specific, but I haven't looked deeply, but I think that may not be the case today. So maybe that might be something to talk about. But I know that Samuel had his TDM project, but that seems like it's I don't know the state of it. But this is a big question mark for me. Is the ABI, is the formats, is the guest user space? So I basically been saying like let's focus on this stuff first. Not here, but up here. This and this the PCI core bits. And get that settled first, and then probably next thing we would do is the attestation and the KVM pieces.
Yeah, one of the things that we may need while pushing the guest bits is also the kind of I think everybody have the support for specifying norms while getting measurements and other details, right? So are we going to have like those SFS files decided now, or how do we specify? Because SPDM series had one way, like, he will specify the norms and then do the get measurements so that the norms value specified in the SFS is picked for that get measurements calls and things like that. So should we spend time sorting that out, or this is only about lock and accept?
Well, I mean, I think for the initial, something that we could merge initially without having a whole other debate would be without measurements. That it would basically be we merge something that says, yeah, you probably want to do some attestation before you accept this thing, but this is at this stage of the kernel, all you can do is accept and cross your fingers that was a good idea. Kind of thing. But yeah, and then we can have all the then we have more time to figure out the measurement stuff. So
what is there really to figure? Because measurements and report and certificates are defined in PCI spec or SPDM spec, and the standard blobs. You just expose them by CSFS or something to the guest user space, and provide lock and accept nodes, and you're done.
There was a discussion of netlink being that interface, not CSFS though, right? Because it's going to be long.
Right. Yeah. There was a question about the interface. I'm not convinced that we actually have all the same formats. Like I think I need to look at what the there's SPDM device attestation info that is in the TDS Connect docs. I want to compare that to what's in the AMD and the CCA stuff to see.
Well, I take all these formats from public specs, so we didn't invent anything.
So have you spoken to James at all about the format, Dan?
James
Beanie?
No.
Because he's the part of the DCAP team, which is Intel's library for attestation primitives. It's the one we publish. And there seems to be, so standard-wise, even though SPDM is the format, DMTF has an SPDM measurement format, I'd imagine, at least currently, if you look at, say, the NVIDIA NVTrust library, they're taking an SPDM measurement and they're turning it into an SPM, so a concise evidence measurement. They use the TCG's SPDM bindings for concise evidence, and they're at least that library has examples with all indirect measurements, basically, as a format that they're supporting. And we are probably going to end up supporting concise evidence as well. So for a user space interface, everything's going to come back in concise evidence to hand over to whatever verifier, which would make sense because all the existing verifiers right now that people use concise evidence, whether it be the Azure verifier that they have, or whether it be Verisone, which is the reference implementation from IETF and TCG. That the formats are pretty standard for what we should return, and we probably can standardize the kernel interface on that as well.
That's what I'm hoping. Yeah. So I think I want to. That's the. I mean, so yeah, we asked a question, Lexi. Like it's these kind of comments are like I feel like there's more work to do to make sure that that we have a common format that everybody can standardize on. Because unlike the architecture specific launch attestation, I don't think we like for PCI standard devices we should have PCI standard format. We shouldn't have to repeat that kind of pain that we did on the DM side.
One of the challenge I have seen is there are multiple options, right? I mean, we can request this measurements with signature, and then and there is also this like transcript which actually includes the request buffer and response buffer. So very early when I was looking at the AMD spec, and it didn't support signature, right? Alex, if I think now it does, right? So that's one thing, right? I mean, are we allowing people to kind of say that I want measurement blocks with signature, without signature? So what they see in the CSFS file would differ. Is it going to be one file with both the request response interleaved, or are we going to have, because for that attestation with signature, for that attestation verification, they need to replicate the request which the SPDM library used. And in our case, that library is the firmware, right? Because it's the RMM sending the SPDM request over the IDE. Now, so expecting the verifier to rebuild that probably is kind of tricky, challenging, because they may not really know what the format is. Maybe they can, looking at the VCA blob, they can recreate it, or the kernel can say, this is the request buffer I have seen. The firmware is sending to the device, and this is the response buffer I have seen. But then the question becomes, how do they interleave, right? It has to be interleaved, the request, response, request. If you are sending all the requests followed by all the response, I'm not sure whether the verify can interleave. So those are the questions I had around that, like with respect to defining the interfaces to the user.
Yeah.
So, and this is why SysFS is not a viable interface for this, right? Because as you just mentioned, like, first off, getting your measurements results back in SysFS gives you no actual benefit, right? Because you want, like 99% of the time, you're going to want a signed measurement, right? Which means you're going to have most likely pulling all the measurements back, and most likely, you're going to need to verify that the M2 transcript, which is what you're talking about there. So if I have to reconstruct the measurements from SysFS files, that's not helpful, right? Because I can't reconstruct the signature. And at that point, you have no trust in the signature that's coming back as a verifier. So if I have to rely on the TVM to reconstruct the measurement, re-sign it, and then send it up to the verifier, there's no trust in the measurements to begin with there as a relying party. So really what you need to do is you need to get a signed measurement back, signed by the device credentials, which is what they're really rooted in, and send that over, which is why I think the netlink interface is the right thing to do.
But why can't SysFS provide this signed measurement? What does imply it has to remove the signature? And
But this is the feedback that we had but Lucas got at Plumbers, like at the point where you're basically doing a transaction.
Yeah.
So you want to atomically get like I want with this nonce with these certificate slots and these measurements. Like SysFS is not good at atomic transactions. It's good at caching static things. Not about running not about having a kind of an input-output interface.
Because even if you wanted to do the single measurement at a time thing, way of reconstructing them. So the SPDM allows you to say, give me measurements, one at a time, and then sign the final measurement, which is where the M2 transcript comes in, and which is what allows you to do that. But even if you were to do that, then you'd have this weird situation where you have measurements. First off, you might not want all measurements. So in that case, having SysFS pre-populate them all is not as helpful. And like Dan said, at that point, you're essentially reconstructing everything on your own. And so I guess the point I'm trying to make is it's not flexible to do it through SysFS. There's no flexibility to do all the different kinds of measurements that you can request from SPDM with SysFS and have it be anywhere close to reasonable. And I'm originally a file system guy, so I like to use pseudo file systems whenever I can, but I don't think this is the right approach for it.
So is anybody looking at that netlink, or like I heard like there is some verifier?
Yeah.
Are they using any kind of like, can we look at that to kind of derive what is needed from the kernel? Is there any reference that we can see?
Yeah, so Lucas has a version of his original SPDM patches that has
yeah, but that was doing inside the kernel where he takes the request, put it in a buffer, he gets the response, put it in a buffer. Like, so the interleaving is done by the kernel. So the kernel knows, because the kernel has control of all these things, right? Now, if the firmware is doing the request, and I was told these buffers can be like too large, right? I was not sure.
Well, but most of the time people don't keep the full buffer. They keep a rolling hash of the buffer, right? Like when you calculate the transcript for the signature, what you're generally doing is you're taking each of the request responses and you're adding them to a rolling hash inside wherever, whether it be inside your DSM, inside the kernel or TSM, whatever's handling it on the client side. You don't usually keep the full transcript.
Okay.
If you want to keep the full transcript, that's something you kind of have to do. I guess maybe you'd have to return the request response to user space for user space to keep it. Well, like you said, that large of a transcript in kernel space makes no sense. And at least on the device
but
side,
Lucas is doing that though, right? In his SPDM patches. Or
well,
maybe I got
there's
that
no
wrong.
measurement support in the SPDM patches right now. Not to the extent we're talking about. Not to where you can see measurement request. So that right now is a gap. So the patches need to be extended to have a get measurement request, which does not exist.
But this is also where I'm throwing up the flag for help that one, Lucas is focused on the native case, and we have like the TSM case I think is different, and we have and a lot of the work for like the actual retrieval is actually done behind ABIs,
Yeah.
and so yeah, I think we need somebody. We do need somebody to take the lead, look at all the vendor implementations, look where they're different, look where they need unification, and then think about a TSM first design for it, and then circle back and see like, is there anything that's reusable for the CMA case? Because before it was like, hey, let's CMA seemed like it might have gone first, and we would reuse that. I think at this point we're on the TSM kind of enabling side. It's ahead, and it should be the first mover, and then see what can be reused for the native case.
So the Linaro team has shown interest. So Matthew from Linaro was trying to write CBOR. I don't know much about this attestation, so I may be getting these terms wrong. CBOR spec, which kind of capture all these details. Maybe I can kind of point him to the Discord channel, and then he can help us understand where he is. Right?
Yeah. Point him there, and then I think I was also going to maybe schedule a conference competing, like in the agenda that Steve Rutherford runs for the kind of the Europe Pacific friendly version of this meeting, to run through that kind of format thing, because that's the time we've gotten the most kind of attestation people involved, like from CSPs and other things, and to see, and yeah, that might be a good place to kind of get on board, get everyone on board with what the format needs to be. But yeah, looking for help there. But this is also why I say like, yeah, let's get accept without a test done first, because I feel like there's a whole other project on this phase 3 stuff. But the other thing I wanted to show, go ahead.
One other details there. This is the last update I have heard from Matthew. I don't know. I just send it to the chat in the. Did you get to see that Zoom chat?
Yeah, I got the link. Yep.
I don't know how useful this is. I haven't spent time looking at this talk.
The EAT Pro. Yeah, I haven't looked at that
Profile
stuff,
for device attestation. They were doing something. It looks related, at least sounds related.
It sounds related. It has all the right words, all the right.
Yeah.
So.
Yeah, I'll point Matthew to the Discord, so we can probably ask. Yeah.
Okay. Yeah, I think we can go full force on that once we get accept done, but yeah, I think if we try to do both, we won't make progress. Actually, I'll say it the other way. I think we can get accept done, and people think that's useful, and I think we can get connect done too, because connect doesn't involve VFIO and IOMMUFD. So I think we can do connect. People can have IDE, and we can have lock and accept on the guest side, and then the rest can fill itself in later. I mean, I do think the staging tree is going to need to carry some hacks there, like whatever, like maybe we'll carry the DMA buff hack and the IOMMUFD like just so people can do the end to end in the staging tree, but it won't be the final solution. And we'll tell people like, this is not the final ABI. This is just so we can we can demonstrate the stuff working in the guest. But But
Do you have any preference with respect to how the patches for the architecture needs to be ordered, like all the bits that is not yet sorted out comes at the end, so that we put the guest, but then the storytelling won't be really nice. So we put the connect part of the driver and the lock part of the driver, and then rest of the driver comes late.
I mean, I think if we have the PCI framework and the threat of drivers being ready for it, I think we can get that merged first, and then you can merge your connect side and your lock side on your own time scale. Or are you talking about for the staging tree itself?
I mean, even for the staging tree. So what you're saying is, so don't bother about architecture specific order, because that will go at the end once we only sorted out everything, right? What I'm trying to say is that, do you want the guest driver related arc changes early on when we are posting like ARM patches, right? ARM CCA guest or ARM
Like, because
CCA host kind of driver that we have.
I think as long as it's based on the core that we've agreed on, then I don't have strong opinions on the order you do it. So whatever is comfortable. I think. I mean,
Okay.
the order you had in your RFC was fine, because for the staging branch, what I'd love to get to is a point where, like, hey, core pieces that we agree upon that are stable and could probably go upstream within 1 or 2 kernel cycles, then maybe a pile of hacks in DMA, buff, MFD, like whatever we think is workable, but maybe not final, but we just need something, and then people can send like pull requests for all their architecture bits, and like and I would just merge them. I won't look at them. I'll just be like, just like Linux next,
Okay.
just merge that stuff.
Okay.
That's kind of what I'm hoping for. But we had a lot of questions. Everybody had a lot of questions about this, and I was kind of surprised, and I should talk through it real quick. Is like, what the heck was I thinking with the changes to guest request? Is this coming through? Can you see this? TSM guest request. The
Yes.
code. Okay. Okay. And let me see if I should open this beforehand. But the firmware control. So have you guys heard of firmware control? Firmware control is this. Well, just take my word for it. This is the prototype for firmware control. Firmware control was a proposal by Jason for the cases where, because with secure boot and kernel lockdown, you can't. It removes your ability to send kind of custom commands to devices, and PCI's lockdown, and so a lot of these there's a lot of devices that need a lot of like debug stuff, special commands to be sent to them, but they're kind of vendor specific, and we kind of needed a way. Linux needed, like, these devices needed a way to do these things in a common way, but these commands aren't the kernel doesn't care about these commands. These are just kind of vendor specific commands, and the concern has always been that if you let vendors do whatever they want, then they bypass the kernel and they do a whole bunch of strange things. And so part of the interface included this scope parameter that basically said, hey kernel, you don't know what's inside of this opaque payload, but we're at least asserting that it doesn't leak secrets, it doesn't change the state of, it doesn't issue DMA. They're like, it's a security contract. And when I look at what the guest request interface is, it is a blind blob that some guest said, "Hey kernel, send this to this device using your admin privileges," which looks very similar to a do whatever you want kind of vendor pass-through path. And so I modeled guest requests to be identical to the format and approach of firmware control. This scope, so you should ask, like, what is this scope thing? I think none of us are ever going to use the where is it? I have it defined. Nobody has any plans to do anything beyond asking for attestation info, asking for the device interface report, and these kind of things, and changing the state from locked to run and unlocked to locked.
Yeah.
But because this is a blind opaque blob, we want implementations to assert that, yeah, we're not trying to exfiltrate potentially security sensitive data. We're not trying to destructively change the configuration of the device, and yeah, so the interface would assert that the thing passing it around would assert that. And if this is the same problem with firmware control, like if a vendor wants to lie and say, oh yeah, I'm just doing a read-only command from my guest to the host, but actually it's kind of a backdoor that this guest has coordinated with the TSM side, and they're doing something else through that path. You would not know, but that would be something that regulators, the market, people can say, like, hey, you are actively subverting a security feature of Linux. And so this was the piece of the safety of the firmware control method that made it acceptable to go upstream. And I don't want anybody to look at guest requests and be like, oh, this is a vendor pass-through. Like it has all the same. It's going to follow all the same requirements of a vendor pass-through as firmware control, and have these scope requirements around it.
But where is the response in this? That's one thing I was missing. Like response buffer is not there though, right?
Right. So this was the response buffer is the return value.
Okay.
So
but if it's I mean, if you have like a certificate chain, like the earlier one had like an info structure, which had like a user space pointer for request in and a user space pointer for response in, kind of a thing, response out kind of a thing.
Yeah. So I mean, but so the difference is whether you should be able to do the exact same thing with this interface. The only difference is, do you want to pre-allocate? Do you want the person making the call to pre-allocate a response buffer, or is it okay for the low-level driver to own allocating the response buffer and then telling you, and then putting how big it is in this output?
Well, a response buffer is always pre-allocated because it's a octal.
Yeah.
So you know how much you pre-allocated. You don't know how much of that is used by the actual guest request. Well, I do. Maybe you don't. But on AMD, it's all like fixed size.
Well, I mean, there's the I mean, there's the octal path, but the kernel side doesn't need to allocate. If you need to allocate on the kernel side, right? Like that, like, so for the case where you make a request to get the certificates, and you go into the thing, you say, yep, yeah, we have a megabyte of certificates, and you can allocate the megabyte. Then when you try to return it to user space, that's when you That's when you discover that the user space didn't give it a big enough
I
buffer.
get what you
Because those are kind of two separate things. Is what is the point?
So that requin is not user space address.
I guess we can make it. We should probably make it. We could make it a user space address. Is it? Are there any kernel internal guest requests? Do we need to make this? We can make it a sock pointer so it can then dynamically be one or either or.
Yeah. So the one that I have done in my case is it's an IOMMUFD ioctl, and then both requin and response out are user buffers, and I just directly pass them because the entire thing is allocated by VMM, and the VMM knows allow. And the kernel just do copy to user or copy from user to kind of like understand. Right. I did point to a link of that implementation in my response while asking.
I do the same thing. And in my case, I still have to copy it to the buffers, which I actually use with the PSP anyway.
Yeah, you're still gonna end up doing the copy. But I mean, but how do you handle the case where the response is bigger than what the ioctl passed in?
I return the code to ioctl in ioctl, like buffer too small, then you have to repeat.
Yeah.
We have to do something like this anyway because it's ioctl.
Yeah. Ioctl are terrible. I mean, I guess they're always bad. I'm just basically trying to copy something that's already in the space for which layer is responsible for which buffer allocation and which sizes. But
that's just this one always copies, extra copy and extra allocation, and if it returned null, what does it mean? It failed or it succeeded, but there is no response buffer to fill.
Yeah, if you return the farmer control recommendation for that is no response is null, or you return the request in buffer size. You return the request in buffer back, and it says, okay, that means there's no response.
Yeah.
It's just error code.
Yeah, I think if you internally allocate a kernel buffer as the output, then maybe we need another memory copy to move this content to user space.
We will have to move content from this newly allocated buffer to user space. Yes, that will be in the MMUFD now, while it could be in the PSP driver or TDX driver on the host, or ARM driver on the host.
Okay, well, I mean,
for Intel, we also need some kernel internal pages to invoke the firmware calls, and then we copy these kernel internal buffers to user space buffer.
So,
then
right,
there's
so
already
you have
and copy. Yeah.
So you already have request and response buffer to talk to TDX, and then you have request and response buffers in the user space. And there's like two buffers, right?
Yeah.
And the user space ones are pre-allocated, and you know what size they are. And allocating third one in between seems not exactly necessary, or it doesn't make the interface all that nice because you have to work with, you have to do extra copy and like, what do you get from this benefit?
So I also wonder why we need a third buffer here.
Okay. I've always said that, like, if I mean, and Alexi saw this in my response to his feedback. He's like, yeah, If you Luna Niche also agree with you, then I'm wrong, and so it sounds like you guys want to go back to. I might still keep the scope because I think that's important to say. Like, yes, there's a security model here. Yes, we're going to adhere to it, and if you have to expressly violate it, but we can go back to just error code and passing in response buffer and response size.
I think maybe it is possible we just as the TSM APIs just accept the user the user buffer and
yeah. Okay. I mean, so just in case there's a because we had this with the attestation APIs where like there are sometimes in kernel internal like the networking layer has something called a sock pointer, so you can, depending on who they call it, they can either pass a user buffer or they can pass a kernel buffer. So I'll switch to that, but I'll let the response buffer be pre-allocated and step away from this internally allocated thing because in case you guys all ganged up on me. That's okay. So I'll switch that. So I'm gonna switch that. I'm going to fix the TSM dev. Like we need to pass TSM dev to connect and lock. Thanks for finding that, Alexia. Like that was a miss on my part. I'll get that fixed right away, and I'll post an emergency urgent fix up branch, and I'll just send the. I won't repost all the patches. I'll just send a small diff because I don't want to spin this while people are still reviewing it. But that'll be a quick fix just so it unblocks people.
And while we're at this, do we have room for firmware response code if say request didn't work? I really like it because I really need it, and I was adding firmware error into this prototype in my tree.
Firmware error. I'm trying to think of how firmware could be. Wouldn't that be in the response buffer? Wouldn't that be
the response buffer is for the guest part, and I'm talking about the error code for the hypervisor, because hypervisor can mess things up as well, right? And you don't even have to send it back to the guest.
Oh, I see what you're saying. Okay, so yeah. Yeah, no, I'll send me a link to your code, your prototype, and I will adopt that as much as possible. And with that,
wouldn't that be a return value of this function PCI TSM guest request if there is a response buffer as an argument?
So there's the error code. So what I'm understanding is there's error code from the low-level driver, and then there's the error code. Wait, Alex. What do you mean the error code from the VMM? This is on the VMM side. This call is on the VMM side.
I mean, if say you want to bind PCI device to a guest, right, and you make this call. Nah, not bind. Say you want to do MMIO validate. So there is MMIO range, and you think there is a guest, there is a device, and you call PSP, and PSP says that there is no such guest. For whatever reason, like host screwed it up because host needs to tell what guest it's for. So there is no point sending this response buffer to the guest. It's the host which got guest context page wrong. So that would be return code from PSP to the host.
Okay.
Yeah,
okay.
That wouldn't be ERR PTR inval. Wouldn't that be the error from the PCI?
You can try and translate all response codes from the PSP, but they're more detailed than just inval.
Okay.
There are a whole lots of reasons why request failed.
How is that a unsigned log? Is that 64 bits of status, the firmware status?
So far it's been 16-bit. So just int will do.
Yeah, I think the important thing is that this error code value is out of the request buffer or response buffer. They are not composed by they are not included in the response buffer that guest prepares. It's an out of buffer value. Yeah. So you basically you cannot you cannot copy them into the
why would
response buffer.
Why would VMM needs to know that, like, so that return value from PSP is coming to a CV module, right? Like the low level AMD module, and it understands, it can decode all those things and convert it into a Linux Erno value, right? Do we need to send that all the way back to VMM?
I think the guest needs to know these firmware error to decide what.
As we said, if the VM doesn't exist, we don't need to send it. If the guest needs to know, it can be encoded in response. I think what we are talking about is the host wanting to know something, and especially the VMM wanting to know something, right? If the host kernel, then the low-level driver, which the callback, right? TSM guest request callback can handle it inside the kernel.
Yeah, but the merit of these direct connection channel is to is not let the host to parse and recompose these request and response buffers. If you if the like the GHCB spec requires that a separate value out of the response buffer, then our software interfaces don't compose its own buffer format. And if you do integrate these firmware errors into the response buffer, then host have the responsibility to recompose the response buffer. Yeah, and build a new contract for guest to parse.
In my case, guest response is encrypted. You cannot really see it on the host or QEMU. And you're curious what failed, then you're gonna have to have it in plain somewhere in addition to response buffer.
Yeah.
Okay. So Alexi, just to get it, you want the VMM to know the firmware response buffer, right? That's the reason.
Because I will get bug report, like it's not working.
Okay. Okay.
And PC can tell you exactly what's not working.
Okay, got that.
It's a you're not going to convey to the guest, right?
I will return the code via DHCB fields.
Okay. So it will be transported back to the guest. The guest might want to know the.
That depends. QEMU decides if it just stops the guest or returns the code to the guest.
Okay. Take a look. Well, we're at the over the top of the hour. Yeah. So yeah. Send me. Keep some more feedback on the patches. I will rework this a little bit quickly, and then we can go from there. Otherwise, I gotta take off here.
1 minute question.
Sure.
Am I the only one who is confused by TSM used for DSM all over the place? Like in this screen in the middle, struct PCI TSM PF0. It actually describes DSM, which is Device Security Manager, isn't it?
The
local variable called TSM underscore PF0. This is DSM, right?
Can you open the line number?
There are no line numbers.
Yeah. Dan, could you set the line number?
Yeah, this one.
Oh, okay.
Isn't that just
it's not confusing for you? I'm asking Yelena or Anish.
Okay.
Isn't that just to handle the
I-
fact that the TSM itself could be a PCI device, and it's asking for the physical function 0 of the PCI device representing the TSM? Because that's how.
and I think
No,
we refer to that as DSM.
TSM is the crypto device, which is CCP, which is not where you enable IDE on. That's TSM, which is Trust Security Manager.
I think
your security
my
manager.
patches had DSM to PCI TSM. Yeah, PCI DSM. Let me just check.
No, I'm okay calling it PF0. Makes sense.
Yeah, for
like cleaner
confuse
and more
me.
obvious.
Yeah, it didn't confuse me too much because for me PF0 was DSM. Like I always look at it that
No,
way.
I'm talking about variable name, which is TSM underscore PF0. That's not TSM. That's DSM. You can ditch PF0 here.
Is this the change you want to see?
And remove PF0.
Yeah, in that case, PF0 is not needed though, right? Because it's implied.
Right. So like this, yes. Isn't it better?
I'm okay with that.
And even struct PCI DSM doesn't need PF0 though, right? The struct name doesn't need PF0.
No. You can keep the struct name as PCI TSM PF0. That's fine because PCI TSM is a prefix of subsystem. You know, I'm fine with that.
Oh, just local variable name. Yeah, that's fine.
And parameters when you pass them around, call them DSM. So that's I keep reading and I keep catching myself on confusing things. I can get used to it, but just.
I don't think
if
DSM...
it's just me, then drop it.
Go ahead, Yulin.
Yeah. I think mostly DSM is referring to the device side, the management on the device side. But we are the host side. I think it is that the post that TSM is communicating with the device side DSM. So I think, in my opinion, TSM is okay.
Yeah. So that I mean that was the original intent, that this is the code. This is the code that
communicates with the DSM.
That's using the TSM as a host controller.
Yeah.
That we actually don't see we don't actually see the DSM side, because everything that we interact with is a TSM abstraction, and the DSM is actually behind. The DSM is always behind the abstraction. That's why the only DSM we have in here really is just to name the PCI device. It's just a PCI dev for that one. Like the definition of what is a PCI TSM device is literally is DSM is basically like it has a TSM context, and the DSM device in that context is this PCI device.
Okay. Yeah.
I don't know. That's Anish, like what's your vote? we need a tie break.
I have it the way you already had earlier. I didn't have the DSM variable. DSM variable was only for PCI dev in my code path also. So what you have currently posted is what I had.
So you're saying you already got used to it, and that's keep it this way.
To me, like the way I translate it, it's like this is like this is the host controller. This is the interface that takes the commands to the thing. But
okay.
I'll fix
it. Just fix guest request then, and be good.
Okay. I'll fix it. Okay, I gotta go, but yeah, hit me up on Discord, or send me email, and we'll keep it going here. Thank you so much for the feedback. I appreciate it, you guys.
Thanks, everyone.
Thank you.
Thank you. Bye.
Cheers.